All right, then. I'd like to introduce Michael Rosen from Lizard Tech. He's got a presentation for us about custom raster formats. Hope you enjoy it. Michael?
Thank you. Hi, I am Mike Rosen, and I'm here today to talk to you guys about our experience implementing a custom image server raster format. So before we get started, I'm just kind of curious who else is here. Has anybody else here written stuff that actually runs inside either ArcGIS Server or ArcGIS Server, image server extension? Okay, yeah, a couple guys? All right. Anybody written a raster format handler? Nope? Okay. So the genesis of this project actually starts at this conference last year, and we'll talk a little bit more about how that actually ended up working out for us. Let's see. Before we get started too far, let me set some expectations here. So in a lot of these presentations, there's a broad spectrum between, on one hand, we have maybe the project management sort of post-mortem kind of presentation. At the extreme other hand, we've got an MSDN style how to do this presentation. This presentation sits somewhere kind of in the middle, maybe a little more towards the, well, what to expect side of this. So I expect to answer questions like, what did you guys get out of this? And how much money did it cost? And did it really hurt? We'll talk a little bit less about specific code stuff like, can you tell me in detail how to implement this particular API that is required by the FormatCore plugin API? So before we answer any of those kinds of questions, let me start off by trying to define what it is that we're trying to do. Lizard Tech is pretty well known in the industry for two things. At trade shows, we give out plastic lizards and the Mr. SID file format. Mr. SID file format being the first wavelet-based image compression format that achieved widespread adoption. Shortly after we began shipping Mr. SID, our customers started asking us, is there some way that we could get this out on the web in a very rapid and efficient manner? And Lizard Tech's answer to that was Express Server. Well, a lot of Lizard Tech's customers are also ESRI customers. And with the advent of ArcGIS Server and ArcGIS Image Server, the question was, well, the question to us was probably the same thing they ask a lot of you guys is, that's great, can you make it faster? And Lizard Tech hears that a lot. And so before we go too much further into that, let me tell you a little bit more about why we think the answer is yes. Let me tell you a little bit more about what Express Server is and what it does. So again, we've shipped this for 5 years, and its primary purpose in life is to take wavelet-based images and make them available to WMS clients, web browser clients, and we'll talk a little bit about a plugin that we wrote that's available that allows access through ArcGIS desktop clients. And it makes these wavelet-based images accessible really, really fast. Beyond that, though, it's kind of a one-trick pony. Things that it doesn't do. It doesn't do vectors. It doesn't do sophisticated raster processing. It won't calculate an NDVI index for you. Those are things that we depend upon other kinds of products to add value later on. But what it does is it goes fast. It takes these images and makes them available out there really, really fast. And the reason it can do that is located down here inside the engine on which it sits. The catalog manager has got a geospatial index which allows us to identify which part of, say, a mosaic of 100 or more Mr. SID images, which part of that mosaic we want to serve out. Then when we do the decoding and serving them out, we maintain 2 levels of caching. The extraction cache is something kind of like a pixel cache, or excuse me, a tile cache, which a lot of other kind of servers have. What we do is we take the incoming URL request, and we hash it, and we take the response that we give, and we store that off in a cache. And if ever we get a request for the same thing twice, it's an order 1 response, and off it goes. Okay, no magic there. The other piece of it, though, is a pixel cache. And that's where we cache the pixels that we pull out of subsequent requests that get asked for a lot. If you didn't know about decoding wavelet-based images, it's computationally really expensive. And so anything that you can do to reduce the load on what it is you need to decode buys you a lot. So by maintaining a pixel cache, we don't have to decode the whole scene every time somebody asks for it. So that's what's inside of Express Server. Now back to the question at hand. So we've got this Express Server, and it serves wavelet images pretty fast. And now we've got ArcGIS Server in the picture. And what our customers are asking us is, well, we'd like to have some sophisticated application maybe based on ArcGIS Explorer, and we want it to serve up raster images, and we want it to be able to consume raster stuff, we want it to consume vector stuff, and we want it to combine that with raster images, and we want to do this scalable so that we've got it running over multiple socks, and we want to be able to do on-the-fly raster processing, and we want all this to be really, really fast, and we want it to be fast not just with geotiff images. No, we want it to be fast with Mr. Sid images and JP2 images, so what are you going to do for us? And LizardTech thinks that if we could plug in right there, that's a problem that we could help solve. So that's what we're trying to do. We're trying to build in that piece right there. And how are we going to do that? To some degree, this is a problem that LizardTech has solved before. So like I said, on our website right now and for the past 4 years, we've shipped a plugin for ArcGIS Desktop and ArcIMS that allows ArcGIS users to consume Express Server-based images into ArcDesktop and ArcIMS. Well, how does that work? When you install that plugin, one of the things that you get is a small, dedicated client who sits on the same machine as ArcDesktop. And when you fire that client up, you tell it, I want you to go out and I want you to interrogate any particular Express Server of interest. And it goes out and interrogates the Express Server, and then for every layer that Express Server exposes, it's going to pull down and it's going to write a tiny text file with an IRL extension, we'll call it the IRL file, that's going to contain the URL of that image on the Express Server. That's a one-time shot. That client finishes its job, and now resident on the same machine as ArcDesktop, we've got a local file system representation of all the items in the catalog on the Express Server. Our task then is we're going to write one of these guys, those custom DLLs, the raster format reader, that's going to consume this IRL file. It's going to be able to tell things like what the spatial reference system is for that IRL file. It's going to be able to tell things like how many layers are in that IRL file. And it's going to expose all of this stuff via RDO back out to ArcGIS Desktop and ArcIMS. And that way, when ArcGIS wants to go out and pull out a scene from this, it knows, oh, it's just like a pyramided TIFF file. And so I can go out there and I can satisfy the scene request by asking for something at layer 7. And it's going to make that pass down through RDO into our custom DLL. The DLL is going to go out there. It knows how to talk to Express Server. It's going to format a minimal request out to the Express Server. It says he wants 256 pixels located right here in level 7. Express Server, using those optimizations that we talked about already, is going to satisfy that request really, really fast, send it back. The custom DLL then will send it back up through RDO and expose it to ArcGIS Desktop, which can render it and do whatever else it needs to do with it. So, we've shipped this for 4 years, something like that. It's tight. It works. We're happy with it. And we think that it should work with ArcGIS Image Server extension. And when we tried it, though, we ran into some difficulties. And when we came to this conference last year, one of the action items that we had was go talk to those guys in Redlands and find out why we can't make this work right. And so we had some conversations with Faraz and with Peter. And the answer was, well, it should work. But really, there's a better answer for you guys. If you guys are actually wanting to integrate with ArcGIS Image Server, there's a better answer for this. And if we're not going to build it on top of RDO, what are we going to build it on? So it turns out that ArcGIS Image Server has a dedicated API for this sort of thing. We'll call it the FormatCore plugin API. And it's unique to ArcGIS Image Server. But you can see that functionally, it does the same sort of things as RDO and the legacy Raster support library. What it's going to allow us to do then is reuse all that software that knows how to query an IRL file, expose the number of layers on it, tell us what the extent is, get the metadata out of it. We're going to reuse all of that software, but instead of exposing it through RDO, we're going to expose it through the FormatCore plugin API. When we came down here last year at this time and talked about, and we were introduced to this API, we got two claims were made to us. They said, first, this was for Oz. He said, well, it's really easy. It's just a bunch of C interfaces. It's easy. It's easy. And the other one was that, yeah, and we did it so that you could make it go fast. So it's easy and it's fast. We'll see how those two claims panned out. But now let's go ahead and step into what was actually involved in building this. So what you're looking at here is on one side is ArcGIS Image Server. On the other side is that plugin, that DLL that we were just talking about. And then the bullet points there are the names of the APIs that we had to implement. So when you build one of these things, there's maybe 27 or so different APIs, and your task is to go out and either implement them or comment them out. For our purposes, we found that we could get away with implementing just about these. I guess there were maybe half a dozen or a dozen or so of these APIs that needed a non-trivial implementation. So we're going to talk through two workflows here for what the ArcGIS Image Server does. In the first case, we'll talk through the one where it actually creates the RPDef file. That is the file that holds everything except for the pixel data itself, on which a given raster server or image service is based. So the first thing it does is it's going to call initialize plugin. That does pretty much what you think that it does. It calls it one time, allows you to do global initializations. Then it calls get image count. For us in the wavelet compression business, get image count here means find out how many resolution levels are inside of that Mr. Sid image and report that. So the number of levels inside the particular image. Then, for every one of those levels, it goes out and it gives us a chance to create the reader. This is that reader, that piece of software that knows how to interrogate an IRL file, knows how to grab the URL, make the call out across the internet, interrogate the server, asking it for the metadata, and pulling it back. So we're going to create the reader, open the image, gives us a chance to open the image that it gets passed in this case, the particular layer. Get image information. So when the API talks about an image, it's not necessarily a reduced resolution subset for us. It could be tiled images. It could be masks. But for our purposes, in the way that when we're talking about JP2 files or Mr. Sid files, yeah, we send back and we say get image information. This is a reduced resolution subset, just like a pyramided TIFF file. We read the geotransform. That's the information that comes out of the world file. We close the image and we deallocate the reader. And then at the very end, when we're all done with this stuff, it tells us to go ahead and shut down the plugin. So with that information back now, the server or the ArcGIS can go ahead and create the RP raster def file that defines the service. The next workflow we're going to look through is what it does when it actually wants to blitz something onto the screen. So now it's got the RPDef file that defines how many layers there are and what the extent of each one of them is. And now we actually want to show something up on the screen. And we can do that. First, it's going to call us, create that IRL reader that knows how to read IRL files, go out across the internet, ask, when it calls open image, it allows us to go out the internet, make sure the file's there, initialize stuff. Getting information, again, tells us that this is, in fact, a reduced resolution subset. And then it gives us a chance to do some optimization here. It tells us the area of that layer that we're going to be interested in. So select the region of interest. And then it's going to call back with read image scan lines from somewhere around that area and say, I want you to give me a buffer filled with pixels starting at this row and proceeding on for this many rows. So our reader then is going to go ahead, populate that buffer, send it back. He calls us back and says, close the image down, again, close the layer down, and destroy the reader. So we did all of that, and we implemented that. In preparation for the talk, I reviewed the project logs that we maintained for this thing. And let's see, on 15 May, we had decided that it was probably more feasible for us to go ahead and build this with the new implementation than to try and push through the RDO difficulties that we were running into. By 30 May, 2 weeks later, we had the initial implementation worked out. We wrote in the project log all the major risks associated with building a FormatCore plugin DLL are retired. So with regards to the first claim that, yeah, it's pretty easy, by and large, that panned out. 2 weeks we were in 2 weeks in testing. Yes! Okay. One more thing I wanted to mention about doing the implementation. So think about it for a second. You're building a piece that's sitting on the server. And yet, when we build this thing, it's helpful a lot of times to be able to interactively step through stuff. Yes, at some point, you're going to need to do debugging remotely on the server and install the remote debugging client and connect to the remote process and do all that. But for the vast, vast, vast bulk of the development, you can do that interactively just through Arcmap. So there's actually 2 entry points for this. The first, when you use the image service extension, this guy up there, in ArcGIS, in Arcmap, it's going to go ahead and it's going to exercise all of those APIs for you. Similarly, once you've created that image service and you've saved it out and it's inside of an MXD file, you can open that MXD file up and it will again exercise those same APIs for you, so that in this case what you can see here is that it's stepping into this piece where we're actually creating the reader over here. So we're creating the reader there. You can see where the breakpoint is. There at the very bottom of the call stack is where Arcmap is. So that was helpful. Okay, so 2 weeks into this, and we've got this DLL right there. That's the guy who's going to be able to read an IRL file and expose how many layers there are and what the extents are, and allow ArcGIS image server to render those kinds of services. How do we make ArcGIS image server know about it? Well, it turns out that for the ArcGIS image server part of it, that's really trivial. This IRL format file is an XML file. It's 4 or 5 lines long. It says, if you see a file whose last name is IRL, I want you to use this DLL, this guy, IRL DLL. That's it. And so you stage that DLL there, this 5-line text file there, you're good to go. What might not be immediately obvious to you is that that's not the whole story. In order to have a seamless workflow, your users are going to need to be able to create image services based on this format using the image service editor plugin. And to do that, this guy creates that UI using a piece of software called the RPDef generator. And there's documentation that talks about how to build one of these and where these dialogues come in and stuff like that. For our purposes, it turns out that we didn't need to build one of these on our own. All we do is we open one file, just like, say, a BMP file. So we were able to copy these XML files these are defined for every one of those formats. So we're able to copy one of those, change some of the names, and so instead of saying BMP something or other, now it says IRL LizardTech Express Server. And now we can tie in to the image service extension inside of Arcmap. So that was a very happy discovery for us. We didn't actually need to implement our own RPDef generator. All right. So we started off talking about the impetus for this project. and we said that the impetus for this project for us was our users kept asking us, can you make it go faster? So the next slide after this is going to show the results of some benchmarking that we did in Seattle using ArcGIS Server and ArcGIS Image Server serving Mr. Sid images. And at this point, I need to acknowledge my colleague Glenn Wave. Mr. Glenn Thompson did the design and implementation of this kind of this benchmarking effort for us. And what you're looking at here are 3 different configurations of ArcGIS Server with the image service extension serving a large Mr. Sid file. Let's start here. The Mr. Sid image file in this case is a picture of Washington, D.C. It's 100,000 by 100,000 pixels. It is 1.6 gigabytes in size. That's compressed. Originally, it was 8 gigabytes uncompressed geotiff. At the top end, bigger than that? Bigger than that. At the top end is a Perl script that's going to go ahead and simulate making WMS requests to ArcGIS Server. And the way that works is he's going to go ahead and each user is going to make 100 random requests of the server, and they're going to be sequential. So start the watch, make the request, the response comes back, stop the watch, make the next request. Do that 100 times. And we're going to simulate that with 1 user doing it, with 5 users doing it, and with 15 users doing it. The first configuration is ArcGIS Server and Image Server pretty much out of the box. So there's only 1 sock running over here. The second one is ArcGIS Server with pooling turned on. So in this case, I think we've got 10 or 15 socks running. So maybe 15 separate processes servicing these requests. And again, reading this large Mr. Sid file off the local file system. And in the third configuration, it's kind of like the first one, except that we've stuck Express Server on that same machine, and it's serving the 1.6 gigabyte Mr. Sid image up through that IRL DLL that we just talked about building. So we're going to install each one of these configurations on the same exact piece of hardware and run these benchmarks and see what the results look like. So for the first case, ArcGIS Server serving through Image Server just with 1 sock, you can see that we got an average response time for 1 guy of maybe 4 seconds or so. And then it gets progressively longer if you add more users concurrently. For ArcGIS Server with pooling turned on, the concurrent cases get much, much better. And if we add LizardTech's Express Server into the mix, we can see that the response time for all of them is pretty good. We get a response time of less than a second for the single user case and maybe 2 seconds or so for the 15 user case. So with regards to that second claim, that, yeah, we built this API so that it would be really fast and really stable, we seem to have been pretty well informed in that regard. That's what I've got. I'm happy to hang around for a while and answer any questions you might have. Thank you very much for your attention. Okay. Questions? All right. Thanks. No. The question is, did we do benchmarking with Express Server on a separate server? And the answer is no. The real interest that we had in this was to see, did we improve the performance of ArcGIS Server? And so in order to make it fair, we had to run everything on the same machine. That's why that was. Yeah? Other questions? All right, thanks.
Great. Thank you very much, Michael.